What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to look at part 6 of our Pandas tutorial series in Python. And you guys know, without any further ado, let's get to it. So, I should mention to you that we are going to kickstart this video by learning about a new type of object that Pandas provides us with. It is called the Pandas index object. So when I refer to index, I'm talking about the same index we've been seeing all along. I'm alluding to the indexer column and just any sort of labels, header rows and so on that a pandas data frame can hold. So just to give you guys a bit of insight, right? You guys know we actually coded this little data frame in a previous video, but you guys know that Nevada, Ohio, those are column names. They form part of the header row. You guys know 2001, 2002, 2000. Those are indices for the rows themselves. So what I'm saying is that 2001 so on, those are basically years. That forms part of the indexer column. The indexer column is what is called an index object, right? So pandas basically has and dedicates an entire object, for indices. So essentially this data frame is more than one object under the hood. Okay, you've got an index object on the extreme left, and now in case you have forgotten, you may ask, what is this index that you speak of, right? What is this object exactly? What does it do? So you see, guys, index objects are basically responsible for holding any labels that we need to give the axis themselves. So by axis, I mean column wise or row wise. So header row, as well as you got your indexer column. Now, it's basically doing that. That's what an index does. The index object can hold metadata about the data frame. So that's what it does. Now, metadata is basically data about data. Think about it, right? Logically, the data frame is holding data, and you have this index that basically tells us more data about the data itself. Because here, for example, we have just these values, which is basically data, and now the index object holds metadata for these values. What exactly? Well, it holds little states, which are basically the header row, as well as a left axis or column axis that basically has the indexer column. Okay, so that's data about data. Now, that is fine. Now, let me show you how index objects work. So, first things first, guys, go ahead, import our package pandas as PD. I'd like you guys to set up obj pd.series. This is the series object that we are creating. We'll keep the simple, do it range of 3. For the index, we will simply pass A, B, and C. Okay, so that's what we have here. pd.series, we've got range, index A, B, C. Now, let's isolate or extract the index object from the series itself, because it's as I told you, right? This data frame is more than one object that has been combined under the hood to give us the data frame itself. The same with the series. The series is basically a one-dimensional array that has ability to actually have a header row, which is basically the name of that array itself, and it has the ability to have an index for querying purposes. So go ahead, let's extract the index from the series. What we'll do is obj.index. Now I'm going to run this, and I want you guys to print index to the screen. And see, this is what we obtained. An object index which contains the values A, B, C, and the data type itself is an object. Okay, so that's fine. Now, just to show you the possibilities, think about it, right, guys? This is an array. The index itself is an array. Okay, so with that, you have the ability to index as well as slice the index itself. So see, index of 0 is basically the first element, which is A, and you can slice this index. So let's do 1 onwards. So that will just give B and C. So that's good. You have the ability to index and slice these index objects. So I should mention as well to you that index objects are immutable. Let me comment that down. Index objects are immutable. What that means is that you cannot modify an index object after creation. You can't delete, nor can you insert. Okay, so that is good to know. Now, what I'd like to actually show you is just to demonstrate in case you are wondering how this works. So suppose I would like to set index maybe okay, so we have three elements here, 0, 1, 2. Now suppose I'd like to set element at 0 at element position 1, right, which is B. I would like to set that to a value of maybe D. Instead of A, B, C, I wanted A, D, C. So I do in a standard syntax index of 1 and I'll set that equal to D. But now when I run this, you guys are going to see we get an error. So that in itself reinforces the notion that the index object is immutable. So that's good to know. Now, what I'd like to show you is how you can create a index object directly from pandas methods. So let's do this. Import pandas as pd. Let's go ahead, call this labels is equals to pd.index, and within the parentheses let's keep this index object simple. So what we can do is go ahead guys, import numpy as well. Import numpy as np. Now there are several ways to generate dummy data. You guys know numpy is our go-to in our tutorials, so that's why I'm just kind of fusing numpy with the pandas package as well. So let's do pd.index numpy.arange of 3. So that's fine. Now when you print labels, this is what you will observe. It's a int 64 index, 0, 1, 2 are the values we have in it. So that's fine, right? As expected. Now, what I'd like you to do is go ahead, create an object, obj is equals to pd.series. I want you guys to understand exactly how data frames and series are made or created. If you understand how a series is made, you will definitely understand a data frame, because logically speaking, a data frame is literally just multiple series that have been joined on the horizontal axis. Okay, so pd.series, let's do within this 1.5, negative 2.5, and we'll do 0 because we are boring like that. So index is equals to labels. Now pay careful attention to this guys. Think about it, right? What we have now is we are attempting to create a series that contains 3 values or elements, and we set the index to that series to be equals to labels, and labels, if you forgot, is actually 0, 1 and 2. So let's go ahead, let's print obj. I will comment labels out here. So this is what we obtained. Okay, and I mentioned this before, the order is respective. Basically the first value in the index object is going to be assigned to the first row of the series object, okay, which is as expected. 0 gets assigned to 1.5, 1 to negative 2.5, and 2 to 0.0. So that is fine. Now what I'd also like to show you is that you basically have the ability to see that they have been fused. Okay, two objects, a series and an index, have been fused to give rise to this single series object. Okay, so how we do that is as follows. Just go ahead, check in a simple boolean statement obj.index is labels. We are checking to see if the index object that is inside this series is actually the index object which is labeled. So when we run this, what you will see is that we get a boolean true. Now that confirms that a series and a data frame is really just multiple Python objects that work together to give us a very neatly formatted tabular data structure. Okay, so that is good to know. Now, what I'd also like to show you, since we are here as well, so I should mention to you that you have the ability to basically store duplicates in an index object. Okay, so as you can see, I just created a new cell. I will import pandas again, and I'm going to call this index object duplicate labels is equals to pd.index. Within this, I will pass foo bar bar. So that is kind of default two very important words in your Python journey. It is often used, especially when you are dealing with dummy data, right? So you guys can use any values you'd like though. The main aim and goal of this little cell of code is to demonstrate and show us that index objects can have duplicate values. Okay, so one index value or label can appear, more than one time in the indexer column itself. So what I'd like to do now is print dup labels, so duplicate labels, and as you can see, it will show up with the duplicates. Now, that is fine. What I'd like to show you next is a very, very interesting and important concept, guys. You guys need to pay careful attention to this one. I will actually mark it with an asterisk. Important. This is something you are likely to ask and use in your journey with the pandas, especially if you are a data scientist or data analyst or so on. Now, it is very important concept that is called re-indexing. Re-indexing is a very important concept that applies to series as well as data frames. Now, what re-indexing means, just to give you some brief insight, is basically, to summarize it, it means to create a new object, object, with the data conformed to a new index. So let me space this over 2 lines. That's what re-indexing means, to create a new object with the data conformed to a new index. I'm going to give you an example, guys. Don't stress about that. That's just a textual or theoretical explanation of what the concept of re-indexing is. Now it's time for the practical example. So go ahead, guys, create the series object with me, pd.series, and within this, let's pass some values. You may type 4.5, 7.2, let's do -5.3 as well as 3.6. So that's good. Now go ahead, create the index is equals to, and let's do this in a kind of randomized order. Let's do D, we'll do B, A, and C. So that's the index that we have for the series object. And remember, I told you it is respective. What you pass to the index gets assigned to the respective positions of the data elements for the series itself. So D, index D will be assigned 4.5, B 7.2, and so on and so forth. Now, to just reinforce that what we are saying is true, you can always print the object out to the screen, and it is as we expect to see. Now, what is this concept of re-index, right? What exactly is this? Now, let me show you guys exactly what re-indexing is. Now, basically, there's a method. It is called, and it is available to be called on a series object as well as a data frame object. So it's the dot reindex method. Okay. Now what we do is the reindex, calling it, when we call it on the series object, we want to rearrange the data according to the new index. Okay. And what we will do also is, by default, if any index values are specified in the reindex function or method and it's not existing in the original index, then what you will find is that it will be placed, or by default it would be filled with an NaN value. Okay, so that was again just textual theoretical explanations. Now it is time to see exactly what reindexing does. So you guys pay careful attention to what the current or existing series looks like, and now we proceed to do the reindexing operation. So object 2 is going to be object 1 but reindexed, and we are reindexing the index to be in the form A, B, C, D. Pay careful attention, guys. What we are doing now is we are changing the order of the indices. We are basically, moving the rows around with their index identifier as well. Okay, so pay careful attention to that. Now I run this script. As you guys will see, the indexer column retained their value that was next to them in the original series object. A had negative 5.3, B had 7.2. We shuffled the rows around, we made A the first row, and the value assigned to it is still the same. Okay, so there's a difference, there's a huge difference between renaming your index column and reindexing your index column. Renaming the index column will not ensure that the values assigned to the index are moved along with the indices themselves. You are just giving different names to the indexer column, whereas reindexing is basically us shuffling the order of the rows in the order that we want. Okay, so I hope that makes sense to you. Now, in case you are wondering, right, what if in this reindex method I passed my list, but I also passed now an index that did not exist in the former or original object. So let's go ahead and actually see. So I'm reindexing the original series object. I'm making it A, B, C, D, but this time there's also an E. Now when I print, as you guys will see, everything is the same except that we have a new index that shows up. But since there's no value for that index in the original, object itself, so it's just been populated with an NaN value here. So that's good. Now, let me show you again another example of the index and reindex method. So I will create a new cell, import pandas as pd. Let's call this object 3 is equals to pd dot series, and let's do here colors. So blue, okay, my spelling blue, let's do purple and yellow. So these are random colors, guys. Now what we can do is index is equals to 0, 2 and 4. So that's good. Now what we can do as well now is, I just want you guys to see what this looks like. So print object 3. You guys probably expected this as well. You get the indices 0, 2, 4, and you have the values, the respective values that basically take on their position. So that's fine. Now, what I'd like to show you is that, you see guys, oftentimes, right, when you're working with data especially, you may need to do some sort of interpolation or filling of values, right? When you are indexing your, series or data frame or any object that you are working with. Now you may need to do interpolation or filling of values. So the one way in which we can do that is basically by using the method parameter. So in times when you need to interpolate or fill in the missing values, you may use the method parameter that is available to us in the reindex function /method. Okay, so I am going to show you exactly how this works, right? So there's a reason why I chose 0, 2, and 4 as our, labels or indices, but I want to show you guys exactly what I mean. So anyway, what we are doing now, right, is as follows. We are attempting to interpolate or fill in the missing values for this object that we have. So what I'd like to do is, you guys can see this is the existing series. Fine, that is good. Now what I'd like to do, let's do obj3 obj3.reindex, and within this reindex method I will say range of 6. So let me take out that print for now. I'll do obj3 is equals to obj3 dot reindex. I'm reindexing the series to have the indices 0 to 5. Remember, the range function is exclusive of the stop value. And now let's just call this on basically print obj3. So I want you guys to have a look at this. This is as expected. Why? Because in the original series object, we only cater for the indices 0, 2, and 4. So it is logical that 1, 3, and 5 do not have any values assigned to them. Now, oftentimes if you'd like to basically interpolate or fill in the missing values, I like to use the term forward propagation, or basically think of it where the missing data point or the missing index value takes on the value of the data label or element above it. So basically this NaN1 takes on the value above it, which will be blue. So there'll be 2 blues. This NaN will take on the value purple. So there'll be 2 purples. This one will take on yellow, and so on and so forth. That is basically what we refer to when we talk about interpolation or filling in the missing values when we are re-indexing. Okay, now as I mentioned, we are going to use the method parameter. The name of the parameter is method, and it's going to be used or called in the reindex function or method. So within the reindex function, what we do is basically method is equals to, and in string form, if fill. If fill. If fill stands for forward fill, in case you are wondering. That's why I like using the term forward propagation. It just sounds more, I would say, real world. Okay, but preference is yours. You can use forward fill if you like. Now, that is basically what occurs. The missing data value takes on the value of the data value above it. That was kind of a mouthful, but I'm sure that you guys get the idea of what I am saying. So now, when I run print object3, when calling method is equals to if fill, as you guys can see, it is as we discussed. We get exactly that. So that is cool stuff. Now, you see, what we just did was the concept or procedure of re-indexing, but on a series. So you may ask and you may wonder to yourself now, exactly how does this concept of re-indexing work on a data frame? So allow me to show you guys. I would like to demonstrate a quick example for you. So import pandas as pd. What I'd like to do now is, let's just call this data frame is equals to pd dot data frame. Within this, I'll do numpy dot a range. I will pass 9, and then I will do dot reshape, and I'll give it the shape of 3 by 3. So that is syntax that we covered in the numpy tutorial series on the channel. Index is equals to a. Let's do c, and let's do D. Now I am going to say columns is equals to, so this is me giving names to the 3 columns. How do we know there's 3 columns? Well, it's because of the shape of the data array itself. It's 3 by 3, telling us there's 3 rows by 3 columns. So let's pass names to these columns. Index keyword is what gives the indexer column along the y-axis or the extreme left, and the columns itself is referring to the header row. So let's do Ohio, let's do Texas, and let's do California. Okay, so that's what we have there. In case you are wondering, what does the data frame look like? I will show you guys now. This is what we have. It's good to know that each time you run the script, your data values should change, right? But that is fine. Okay, no, my bad, guys. It won't change because we are using the arange method. So that is fine. Now, anyway, that's what the data frame looks like. This is as we expected. The columns are showing up as we wanted. The index itself is A, C, and D, which is as we see. And the data contained within this little data frame are the values 0 to 8. That is because of the arange function that we see there. Now, let's proceed to re-index this data frame. So just for this demonstration, I am creating data frame 2 is equals to data frame dot reindex, and within this, let's pass the new indices for the indexer column. So let's do A, I want to do B, I want to do C, and I want to do D. Now, basically think about it. ACD, that's kind of, I would say, not really feasible because we are missing a data, index. In the actual sense, it should have been ABC, right, or any other letter, not ACD. That can lead to confusion. So what we're doing to fix the data frame is just we are adding a B, and there's no data that we have for B at the moment, right? So it's going to display us as A, B, C, D, and in actual sense, all the values for B should be NANs, as we saw in the demonstration with the series object. So data frame 2, and as you guys see, this is exactly what we expected. Okay, now this makes the data frame much more, I would say, query friendly, because we are working with indices or the indexer column that is neatly created. There's no missing values in the indexer column. Think about it, guys. The whole point of the indexer column is to make life easy for us when we are querying the data frame or whatever table we are working with. So how inconvenient will it be to have missing data in the basic index of the table itself? Now that can be a very cumbersome process to work with, and it can lead to errors in the data itself when you are querying. So that is all good and done. Now, what I'd like to show you, right, is you may ask yourself, right, you may ask, I want to re-index the columns of the data frame. How do I do this? So let me demonstrate that for you. Now let me comment re-indexing the columns of the data frame. So this session is one that I am finding really very interesting. I love sharing all these little technology tutorials with you, and I hope you guys are also finding this fun. So let's move forward, re-indexing the columns of the data frame. What I'd like to do now is, remember, we are still working with data frame 2. So I want to do this. Data frame 2 is equals to data frame 2 dot reindex, or maybe to keep things simple, guys, what we will do is create a new data frame 3, and it can be using data frame 2. Okay, so we'll have two separate objects for data frame 2 and 3. So data frame 3 is going to be set equal to the re-indexed version of data frame 2, and on data frame 2 we will re-index the columns to create data frame 3. So we'll do columns is equals to states. So I actually forgot to do something very important. Basically, guys, you see when you are re-indexing the columns, right, you are attempting to shift and add any columns that you want to add to the data frame. So what you'll do is you'll basically create a list object that contains the new values for your data frame, the new values for the columns that you'd like to use for your data frame. So let's do Texas. Now remember, in the data frame we are working with, we have Ohio, Texas, and California. So let's go ahead. Let's maybe do Texas. I want Utah. Utah is not there, so we expect this Utah column to show us only NANs. And we'll do California. So we left out Ohio. Okay, so that is good. Now this will remain as is. It's basically data frame 2 dot reindex columns is equals to states. And now when I print data frame 3, it is exactly as we expect. Utah has to show all NANs. Texas and California are still showing one NAN each. Why? Because that entire row for B did not have any values assigned to it. Even in the original data frame, California's B index had NAN as well as Texas B index. So that's fine. Now, all in all, this is how we re-index a pandas data frame. So at the moment, we've just seen how to index and re-index a series as well as a data frame. So I think that's about it that I'd like to show you for this video, guys. We did cover quite a bit of good information for this, tutorial video. Now, in the next video, I am going to definitely explore more concepts from, pandas with regards to series as well as data frames. So thanks for watching. Thanks for staying till the end of the video. Subscribe to my channel if you have not subscribed as yet. Like this video so that the YouTube algorithm recommends it to other aspiring individuals out there. And with that, thanks for your time, guys. Good luck with your work, and I will see you in the next YouTube video.